Chapter 7, Similar Polygons. Today we're going to cover Section 7.1, Ratio and Proportion. Your class opener. Number 1, reduce the fraction 20/35, and 2, state two fractions that are equivalent to the fraction 4/6. Our objective today, after studying this section, you'll be able to express a ratio in simplest form. A ratio is the quotient of two numbers, a divided by b, usually written as a fraction a over b, or sometimes with a colon between a to b. Where have you seen a ratio used outside of school? A simple one that I think of that you might have seen is if you ever made frozen orange juice from concentrate, sometimes they tell you the ratio is mix 1 can of orange juice to 3 cans of water, so that would be the ratio of 1 to 3. Or in two-cycle engines where you have to mix oil into the gas, they have various ratios depending on the device you're using. Looking at a problem. ABCD is a parallelogram. Find the value of each ratio. So number 1 wants the ratio of AB to BC. So I'm just going to start by writing them down. AB, I see the top is going to be the same size as the bottom. So AB is going to be 10. BC, they have listed over here as being 6. And then I think of 10 to 6 as really just the fraction 10/6 and reduce the fraction. Well, they're both divisible by 2, so I can reduce to 5/3. Or if I want to, I could have left it written with the colon as 5 to 3. So if you want to turn them into fractions, that's fine. If you want to leave them written with the colon in between, that's fine too. Let's look at number 2. The ratio of BC, which I can look as 6, to AD, and I notice the left side is the same as the right side, so it's 6 to 6. And if I reduce, they're both divisible by 6, so I get the ratio of 1 to 1. Number 3, the measure of angle A to the measure of angle C. Well, the measure of angle A, if I look, since it is a parallelogram, side interior angles have to be supplementary. So since angle D is 70, angle A is going to be 180 minus 70, which is 110. Angle C, I know opposite angles are congruent, so angle C is also 110 degrees. And 110 to 110 reduces to 1 to 1. Number 4. AB to the perimeter of ABCD. Well, if I look, AB is just the top, so that's going to be 10. The perimeter of the entire shape, so add up all 4 sides, and you get 32. And now I just need to reduce 10 to 32. So it looks like they're both divisible by 2, and it reduces to 5 to 16. Write each algebraic ratio in simplest form. So all we're going to be doing is reducing and remembering that the rules for exponents is when it's a division problem, you subtract them. So I start just by reducing 6/12. I know 6 goes into 6 once and 6 goes into 12 twice. So if I'm thinking about my answer, so far I have this. The a squared and the a, if I'm subtracting exponents, I'm noting that the bottom is an a to the first. 2 minus 1 is 1. Bigger exponent in the numerator, so I'm going to get an a to the first up in the numerator. The b doesn't reduce with anything in the denominator, so there's no change. The c doesn't reduce with anything, so no change there as well. Number 6. I noticed that there's a parenthesis group in the top, and you might be inclined to distribute it, but don't distribute. You actually want to leave it factored. If I look at the bottom, I notice I can actually factor the denominator. They both have a 3 in common. So if I factor a 3 out of the denominator, I'm going to be left with an a minus b. And if I look at reducing, I can actually reduce the a minus b's, and I'm left with 2 in the numerator and 3 in the denominator. Simplify each ratio. The big thing here is they have to have the same units. So 4 feet to 10 feet. I'm going to rewrite this as a fraction just so I can sort of look at something a little different. So if I think of 4 feet over 10 feet, the units will actually cancel out. So the feet are gone, and now I'm just left with reducing the 4 and the 10, and they're both divisible by 2, so I'm going to get 2 to 5. So as long as the units are the same, they're going to cancel out of the problem. So that's sort of the issue here with number 8. I have 10 inches and 2 feet. So I either need to convert both units into inches or both units into feet. And I think it's probably easiest if I convert 2 feet into inches. 2 feet is going to be 24 inches. At this point, I realize that the units are going to cancel each other out. And I now just reduce between the 10 and the 24, and they're both divisible by 2. So I get 5 to 12. Number 9, need to convert either both into centimeters or both into meters. Well, I know every meter is 100 centimeters. So 3 meters is really going to be 300 centimeters. Now that the units are the same, the units are going to cancel. So I have to reduce between 250 and 300. First thing I notice is I can just cross off a 0 on each one. So now I'm really reducing between 25 and 30. They're both divisible by 5, and it reduces to 5 to 6. Number 10, 20 meters and 6 kilometers. Well, I know kilo means 1,000, so 6 kilometers is really the same as 6,000 meters. Going through and doing my reducing, I know that the meters will cancel. I know a 0 for each one will cancel. So reducing between 2 and 600, they're both divisible by 2, so I get 1 to 300. Solve. A telephone pole 7 meters tall snaps into 2 parts during a windstorm. The ratio of their 2 parts is 3 to 2. Find the length of each part. So if I make myself a simple drawing. So here's the original telephone pole. It's 7 meters tall, and it ends up snapping in half. I shouldn't say in half. It ends up snapping into 2 parts, and they're in the ratio of 3 to 2. So if I think of the 2 parts in the ratio of 3 to 2, well, if I want to figure out how big they are, let's use a variable and call this piece 3x and the other part 2x. And I know if I add the 2 pieces together, it's going to equal 7 meters. So let's get our equation. So 3x plus 2x is going to equal 7 meters. Well, that's really just saying 5x equals 7. Divide by 5. And I'm just going to leave it as the fraction 7/5. We can also turn it into a mixed number. But now knowing how big are each of the parts, well, the top piece is 3x. So if I want to figure out the top piece, I really need to take 3 times 7/5, which is going to be 21/5. And at this point, I'm going to actually turn it into a mixed number. So 21/5 would be 4 1/5, and I'm going to put my meters on it. And if I look at the bottom portion now, the bottom portion is 2x. So if I figure that out, I really need to take 2 times the value of x, which was 7/5. Well, that's going to be 14/5. And I know 14/5 is the same as 2 1/5. I'm sorry, 2 4/5. And then sort of a quick double check. They're in the ratio of 3 to 2, and I can even look if I add the 2 of them together, 4 1/5 and 2 4/5, they do indeed add up to the 7 meters, the total that the pole was to start. Number 12. The measures of 3 angles of a triangle are in the ratio of 2 to 2 to 5. Find the measure of each angle. So I start by just drawing myself a generic triangle. I know they're in the ratio of 2 to 2 to 5, so 2, 2, and 5. So I'm going to actually put an x by each of them. So the angles would be 2x, 2x, and 5x. I know that if I add up all the angles in a triangle, they will all add up and give me 180 degrees. So looking at an equation, I would have 2x plus 2x plus 5x, all adds up to 180. Well, put all of the x's together and you get a total of 9x equaling 180. Divide by 9, and we get x equals 20. But now I need to come back and actually figure out how big are all three angles. Well, if x is 20, this angle is going to be 2 times 20, which is 40. The bottom left angle is going to be 2 times 20, which is 40. And the angle on the bottom right is going to be 5 times 20, which is 100. And that seems to work out nicely because all three of the angles then do add up to give me 180 degrees. Okay. The last part, a proportion is just an equation that states that two ratios are equal. You've seen these before. It could be something as simple as 2/3 is really the same as 4/6. And if we go through and number the terms, the fraction on the left, the top is the first term, the bottom is the second term, and then going over to the right, the top is the third term and the bottom is the fourth term. And your closure. My best experience with math was when